Right, this is from the packet. This is the perpendicular lines, questions and proofs. So perpendicular lines are two lines that form four right angles. Four right angles. So again, we define perpendicular lines as two lines that when they intersect, they're going to form a right angle. If they form one right angle, though, they're going to end up forming four right angles. Because if you have one right angle, we know that vertical angles are congruent. So this is a right angle. We also know that these would be a linear pair. So 180 minus 90 is going to be 90. So that's a right angle. And then that's a right angle. Okay. So if two adjacent angles are formed by perpendicular lines, then they are complementary. Complementary. All right, so again, complementary were two angles that add up to 90. So if we have two adjacent angles that are formed by perpendicular lines, then they're going to be complementary. I don't like this sentence really. It's just kind of confusing a little bit, but I think they're looking for complementary there. Two angles that add up to 90 are complementary angles. Okay, here we're given that RV and RS are perpendicular. So these rays are perpendicular. Okay, perpendicular means that they form a right angle. So angle VRS is a right angle. And this is because of the definition of perpendicular. And the thing we didn't mention, this was our symbol for perpendicular. The upside down T, that's our perpendicular sign because it's showing two lines that are perpendicular to each other. Okay. And then B here, if the measure of angle VRT is x minus 4, and the measure of angle TRS is 3x plus 2, find the value of x. So we have the two pieces add together to get the whole part. So we would have the measure of angle VRT plus the measure of angle TRS. It's going to equal the measure of angle VRS. Right? This angle plus this angle equals the whole thing. So that's going to be x minus 4 plus 3x plus 2 equals 90 degrees. We know the measure of angle VRS is 90 because it's a right angle. Combine like terms, that's going to be 4x minus 2 equals 90. We can add 2 to both sides, and we get 4x equals 92. And then we can divide by 4, and we get x equals 23. Check and make sure 23 is right. We can substitute it in. So 23 minus 4 is going to give us 19. And then 3 times 23 plus 2, that's going to be 71. 71 and 19 is going to add up to 90, so we know we have the right answer here. X is going to be 23. The second question here. Okay, it's telling us that NO is perpendicular to PQ. So NO perpendicular to PQ means perpendicular here means that they're going to form right angles. So we have right angles. You know, the measure of right angle is 90 degrees. So we're going to have 5x plus 11 plus 4x minus 2. Those are complementary angles. They're going to add up to 90 degrees. Small angle plus small angle equals the whole thing. So 5x plus 11 plus 4x minus 2 equals 90. We can combine like terms and solve. So we get 9x plus 9 equals 90. Subtract 9 from both sides. We get 9x equals 81. Divide by 9, and we get x equals 90. Okay. And you get to check that answer. We can plug it in. So 5 times 9 is 45 plus 11 is 56. Right? 5 times 9 plus 11 is going to be 56. And then 4 times 9 minus 2 is going to be 36. It's going to be 34. 56 plus 34 is going to give us 90. Okay, then we need to find y. So we notice here that these two angles are vertical angles. We know vertical angles are congruent. So we know that 56 here is going to equal y. Vertical angles are congruent, their measures are equal. So if this is 56, this one's also 56. So y is going to be 56. Let's look at the proofs now. So here we have perpendicular lines and proofs. So these are the two processes we're going to use. So the first one we can use, we have our given, right? So they're going to give us that. For both these situations, they're going to start when we're given that the lines are perpendicular. Okay? So if we know the lines are perpendicular, we know they intersect and form right angles. So we know angle 1 is a right angle. So angle 1 is a right angle. Okay, and that's your definition of perpendicular. Abbreviated definition perpendicular. If two lines intersect, they form right angles. That's definition perpendicular. And then we know if we have a right angle, we know by the definition of what a right angle is. A right angle is an angle whose measure equals 90. So the definition of right angle tells us that the measure of angle 1 equals 90. So the perpendicular means it's a right angle. So if it's perpendicular, it means you have a right angle. And if you have a right angle, you know the measure equals 90. Okay. Right, so right angle, so we know angle 1 is right angle. And then this means the measure of angle 1 equals 90. I think that's what I want to say here. So we're going to look at a proof here. The first one is what we're going to use for this one. So we're given that KA is perpendicular to AT. And we're given that the measure of angle PAT is 20 degrees. So this is our given. We're going to use the fact that we have perpendicular, just like we did up there in our process. As soon as we have perpendicular lines, we know we can use the definition of perpendicular. So definition for perpendicular. You can abbreviate it if you want. We know the definition of perpendicular tells us that this angle right here is a right angle. So here's our two lines that are perpendicular, AT and KA, KA and AT. So that means this angle here is our right angle. So that's angle KAT. Is a right angle. And since it's a right angle, we know by the definition of right angles. Definition of a right angle. We know that the measure of angle KAT is going to be equal to 90. Right? So angle KAT is a right angle, therefore the measure of angle KAT is 90. Okay, they're giving us the reason here. It's the angle addition postulate. And if we notice, we have to find the measure of angle KAP, which means we're going to have to solve for something. If we're solving for something, we need an equation to solve. And since we have angles, the only way we can get an equation is to use the angle addition postulate. So if we remember, the angle addition postulate will tell us if P is on the interior of angle KAT, then the measure of angle KAP plus the measure of angle PAT, right, the two small angles add together to equal the measure of angle KAT, the big angle. The two parts add together to make the whole. Right, this angle plus this angle equals the whole big angle. From there, that's our angle addition postulate. From there, we can substitute in what we know. So we know that the measure of PAT is 20. And we know the measure of KAT is 90. So we can substitute those in. So we're going to have the measure of angle KAP. We don't know that one yet. Plus 20 is going to equal 90, right? So this gets substituted in here. 90 gets substituted in for KAT. That's substitution. Substitution. Property of equality. Then from here, we just need to subtract 20 from both sides. So that's the subtraction property of equality. We subtract 20 from both sides. We get the measure of angle KAP equals, 70. You subtract 20 from both sides. And that's what we're trying to prove. Right? That's what we're trying to prove. So we're good. So we started by using the fact that we had perpendicular lines to show we had a right angle. Once we had a right angle, we knew the measure was equal of that angle was equal to 90 because that's what right angles are. Right angles are angles whose angle measures equal 90. And so these three steps should be automatic when you have perpendicular lines. And then we were trying to show that the measure of angle KAP is 70, so we need an equation. We have to use angle addition postulate to give us an equation. We can then substitute in what we know, subtract 20 from both sides, and solve. Well, let's go back up and now look at our other process that we have, which is the right angle theorem. So the right angle theorem, okay, we know that the definition of perpendicular, we'll abbreviate it, definition perpendicular there, tells us that angle 1 is a right angle and angle 2 is a right angle, Okay, so angle 1 and angle 2 are right angles. That's the definition of perpendicular. And we could say then by the definition, like we did up here, the definition of a right angle tells us the measure of angle 1 equals 90 and the measure of angle 2 equals 90. And then we could use the transitive property to show that the measure of angle 1 equals the measure of angle 2. And then we could use the definition of congruence to show that since their measures are equal, they're congruent. Okay. What we're going to do instead is we're going to use the right angle theorem. The right angle theorem says all right angles are congruent. So since we have two right angles and all right angles are congruent by this theorem, we can say angle 1 is congruent to angle 2 because that's what our right angle theorem says, right? Angle theorem. We can abbreviate that RAT, right? Okay. Right angle theorem. So all right angles are congruent. So you got two right angles. Well, they're congruent because the right angle theorem says all right angles are congruent. If we wanted to go ahead and prove this, though, again, it would be the same process. Since the right angles, their measures both equal 90, therefore their measures equal each other. Since their measures equal each other, they are congruent. Okay. Instead of writing all those steps out, we can just use the right angle theorem and say angle 1 is congruent to angle 2. So let's look at the example proof. Okay. Example proof here. So we have our given is written for us. Now we can use our given. So it's telling us AB, actually let's do a different color. AB is perpendicular to BC. AB is perpendicular to BC. That's going to tell us this angle right here is a right angle. So that's going to tell us angle B is a right angle. And we can use this piece of information, DC and BC. That's going to tell us that that angle is a right angle. So that's angle C. So we also know angle C is a right angle. Okay, that is our definition of perpendicular. Definition, again, I'm going to abbreviate perpendicular. Well, we'll write it out. Definition perpendicular. Okay, tells us that since AB is perpendicular to BC, B is a right angle. Since DC is perpendicular to BC, angle C is a right. It should be angle C. Angle C is a right angle. Okay. And now we can use our right, since we have two right angles, we can use our right angle theorem. Or RAT, to say that since they're both right angles, they're congruent. Because the right angle theorem says all right angles are congruent. So this is going to say angle B is congruent to angle And that's really it. We have solving, knowing since lines are perpendicular, the angles are right angles, and therefore their measures equal 90, and we can use that to help solve. So you can add up complementary angles and set them equal to 90. And then we have the two proofs, the two types of proof. The one uses the right angle theorem, right? You're going to use definition of perpendicular to show you have right angles. Since you have right angles, you can use the right angle theorem to show that those angles are congruent. If not, we're going to use the process we did up here. So we need to say these lines are perpendicular, that's given to us. Therefore, by the definition of perpendicular, we have a right angle. And by the definition of right angle, our measure is 90. And then you can use that to substitute into whatever equation you need to substitute that into. You have to come up with the equation first and then substitute it. Okay, so that's for perpendicular lines.